put your project under the CI, right? So what it means is you want to do continuous integration for a particular application. There are multiple ways you can set up your project. One is through the UI, what we have seen. The other is you can create programmatically by using the pipelines. So in Jenkins, there are 2 or 3 terms used kind of interchangeable. Things like a build or a project or a pipeline, for example. Pipeline and project are both same things. It's basically a configuration for a particular application to do continuous integration. When we look at how to do the UI-based project, you go to the Jenkins UI and then build up a pipeline. Or you can do it programmatically. Programmatically means whatever we are doing it manually, right? You can create the same thing by using a program. So in Jenkins, if you want to build programmatic pipelines, you need to use a Jenkins DSL syntax, which is, if you look at Jenkins architecture, Jenkins is built in Java. Okay. So the whole Jenkins orchestration engine is built in Java, but it is based on plugins, and then you can make changes to that, or you can create pipelines, configurable pipelines, using something called a Groovy syntax. Okay. So Groovy is basically a scripting language, okay, like JavaScript, for example. Okay. So if you want to do something programmatically in Jenkins, you can use a Groovy syntax. So the way Groovy works is underneath it has a JVM, Java Virtual Machine, and that can compile your Groovy files. Okay. So, and again, you don't need to learn the whole Groovy language syntax. Good thing about Jenkins pipelines is that it has something called DSL, domain specific language. So instead of writing programs in Groovy, what you will typically do is use that DSL to provide an input, which will be then converted to Groovy, and it will run it. Okay. So what is Jenkins DSL and what is the pipeline DSL? That's the main thing. Okay. So pipelines are basically used for implementing continuous delivery solutions. So it's the same thing as your project. Okay. What are the advantage of doing this? Right. So basically, it is a scripting using a Groovy syntax, a Groovy language. Okay. You don't need to learn the syntax. If you wanted to do certain tasks in Jenkins programmatically, Jenkins has something called a script generator, a snippet generator. So you give it a task and it will generate a script for you, and you use that script. You can copy and paste that script into your pipeline. Okay. So how does the how's the pipeline syntax work? Here is an example. So when you look at your project, right? I said project and pipeline are similar things. It's basically both of them, right, are part of the Jenkins orchestration. What is the orchestration? Same thing. You check out the code, you build the code, you test, you generate a quality, and then workflow ends. Okay. So you do the basically get the code, build the code, and do this. These sequential steps are called stages in pipeline. Okay. So if you look at the pipeline structure, it's kind of a tree structure. Okay. Let's look at a better view. So there are certain keywords you need to know if you're going to do your pipelines or processing programmatically in Jenkins. The topmost concept is something called a pipeline. So if you want to build a project, you will call it pipeline. So single pipeline means single orchestration. So if you want to build a single project, you will create a single pipeline for that. What does the pipeline contain? It has certain key modules. Okay. So it is a concept of a node. Okay, node or an agent. That's a pipeline basically runs on a node or agent, right? So when you specify a pipeline, you need to specify a node or agent on which the pipeline will run. Okay? And then you have stages, right? A stage could be a build stage. A stage could be a testing stage. A stage could be, some cleaning stage, right? So you can divide your pipeline into the sequential stages. What does each stage contain? Each stage contains steps. What is a step? Step is a single executable task. Everything else is just a concept. What actually executes is a task. Okay, we call it a step in the pipeline. Okay, so pipeline is made up of stages. Each stage is made up of steps.
What is node again?
Node is on which your pipeline will run, who will execute it, like an agent, for example, right? So node is a particular computer on which your pipeline is going to run. Okay. So ultimately, each step is an executable task, right? So for example, if you say, hey, I'm going to create a stage called build. In my build stage, I will have these steps. I will first check out my code from a repository. That will be a step. After I check out my code, I'm going to run a Maven build step. So that's another step, right? I'm going to run a Maven command, right? After the Maven command is run, I'm going to run my JUnit test, for example. So that's another step. So that stage has 3 steps, right? Or I might have a stage saying clean, where I'm going to go and delete a directory, for example. So delete a directory is a step, your stage is a clean. Make sense? So in the pipeline, you build your stages, and in the stages, you define the steps and what kind of steps you want to execute. Again, plugins also play a part here, right? So whatever you write in your step is a task. The task is exposed by a plugin. So for example, if I want to check out the code from Git repository, right, I'll be using a Git plugin command saying, hey, Git check out whatever, for example, right? I can also have generic tasks. So for example, let's say there is no, let's say there is one tool which you want to run in your pipeline, but that tool does not have a plugin into your Jenkins, right? But that tool you can run using a Windows command or a Linux shell script, right? You can put Windows command or a shell script as part of your step in the pipeline. Make sense, right? So that's how you build your pipelines. Okay, that's how your pipeline structure works. So these are the only few keywords you need to know in order to build a pipeline. So how does the pipeline look like? It looks like a kind of a JSON structure, right? So you have module, and then start of the module, end of the module. Start of the module, end of the module is the curly braces, right? So pipeline is a single module, right? Which contains things like agents or nodes, then stages. So stages also has a start and end. Stages are sorry, that's not this. Stages are within the stages, you have multiple stages. So you might have a build stage, you might have a test stage, you might have a deploy stage, for example, right? And then within a stage, you put the steps. That's a hierarchical structure. This is your tree structure. With a single root, pipeline is your root. And then you build your structure based on what kind of workflow you want to build. So this is your orchestration, this is your workflow. This is where you are going to put all the steps to execute. Okay. So if you wanted to do this, so the question is, why should I do this, right? Why can't I just use a UI, which I was using right now, right? Create a project, provide a Git repository. So I don't need to know the commands, right, or steps. It can do it by itself, right? So why would I do it programmatically? Okay. So the key, that not one or two reasons, but there are a few key reasons why you would do that, right? One of the DevOps concept is infrastructure as a code. Have you heard of this concept? Infrastructure as a code, right? What does that mean? Why would you do that?
So you don't have to have a
Is that the reason why we do infrastructure as a code? So infrastructure as a code is a very important concept in DevOps, right? Meaning we want to manage whatever we do in DevOps, right? We want to manage it as how a developer manages their code. And what is the key reason behind that is that you can do a version control and change control. Make sense? So like when you're setting up an infrastructure saying, hey, I have 3 servers, right? And I want to install Linux on each of them, and I want to install Apache on that, right? So you can go and do that. Make sense, right? But let's say somebody goes and closes one port on Apache on one of the machine, right? How would you know about it? When somebody complains that, hey, I'm not able to access your site, and then you go, oh, somebody closed the port, now you have a problem, right? Because somebody did some change without notifying anybody, right? If you are doing strictly that using a code, there is no way you can change that without noticing, right? So if you're using a version control system like Git, right? So that's the same thing you are doing as a code, right? So say define your 3 servers and you say on all these 3 servers, I need Apache versions this and all the ports running. Now anybody who wants to stop the port or stop the Apache will now have to check out your code, make the change, check it in, and then it will be deployed. Make sense? So now you will know exactly who made that change, when they made that change, and why they made the change. This is why infrastructure as a code is very important. Though you are able to do things manually, right? If you do strictly with the code, right, the way developers do the coding, right, then you will be in control all the time. You will know exactly what is in your infrastructure right now based on looking just at the code. If anybody wants to change anything, they will go through the same way the developer do it, check out code from the Git, make the changes to the infrastructure, commit the changes, deploy the changes, and now you know what is the difference between version 1 of your infrastructure and version 2 of your infrastructure. Make sense? Same thing, let's say we created a pipeline just now, right? So we created a calculator project and we said, hey, put a Cobertura, put JUnit report, right? And then you're happy, everything is good, you're checking your bills. Somebody logs in and then removes your Cobertura option and saves it, right? Next day you see your bill, oh, I don't see my code coverage. Then what are you going to do? Are you going to look at what happened? Let me check the configuration. Oh, somebody removed Cobertura. I don't know who did that and why they did that. Make sense? If you're using your UI, you will not be able to do that. You will not be able to find out who did that. As far as somebody has access to Jenkins through username and password, you won't know that. Jenkins doesn't know. Jenkins doesn't care. Like if you want to change, you can just change and save it. Make sense? That's a problem. If you're managing 10,000 projects through Jenkins, if people start going to your UI projects and start doing stuff, funny stuff, you'll be spending the whole of your days to find out what happened to which project. Make sense? Access control you can put like, but there are 100 people managing it. Makes sense? So it's better to do it programmatically so that anybody who makes a change will go through that whole cycle of check-in, check-out, and version control. So now you know, like, oh, somebody for some reason removed commercial option from this project. Then you can go and ask that person, like, why did you do this? Make sense? So that's what the whole point of infrastructure as a code is. Means you maintain your infrastructure or manage your infrastructure, same way you developers manage their code through version control. So any change has to go through that process. Because if somebody makes a change, then there will be a process for somebody to review the PR. Once they approve, then only the change can be deployed, for example. Right? Same thing here. If you use pipeline syntax, that means you are writing a code to deploy your pipeline. So now you need to change it, or somebody needs to change it. They have to check it out from the version control system, make a change, make a new version, get it reviewed by the lead. Once they agree, then you basically deploy that code, deploy that pipeline. Make sense? Right? Okay, so how does it look like? Let's see. Here's an example. So this pipeline says agent any, means this pipeline can be deployed on any agent. Okay, if I wanted to restrict to only Linux agents, I would label it agent Linux here, for example, right? So it would say that this pipeline can run only on the agents who are labeled as Linux. Okay, so you can do that. And the stages you see here, stages, the first stage is clean. In the first clean stage, what are the steps? A single step called delete directory. So basically, it is deleting the workspace. Once this stage is over successfully, then it goes to the next stage, build. In the build, what are steps? First, we do git. So, hey, get me the code, right? So git and then the URL from which you want to clone the repository, right? And then it runs a maven command, clean package. Make sense? This is what you have been doing in the UI, right? Maven goes and provide that. This is a similar Windows command which runs a maven. Okay. And then it says, once it is built, this is the post-build stage. What it says is, if it is successful, then generate the JUnit report, and then whatever the application or artifact has been built, save it to the archive. So basically, whatever the application is built is saving to some place from where you can deploy that. Then you can start your CD pipeline. Right? This is one of the simplest example of how to build a pipeline. Okay. Once you have done that, once you have written the code for pipeline, then the question is, where are you going to store this code? Because you want infrastructure as a code. You want this under the change control. So you are going to put this code inside a Git repository. Typically, what happens is that each project, right, which has a pipeline, they are going to have the pipeline code as part of the repository. And then what you do is you can set up a pipeline using a Git repository, saying, hey, execute this build based on this pipeline. Make sense? So what we will do is, we have our calculator project, right? For the calculator project, I have a pipeline here. You see here, Jenkins file and Jenkins files underscore build, right? So let me show you that. So let me put that in the chat. So you can go to my repository and look at the pipeline syntax. Open up the Jenkins Win file. This is the pipeline code which does exactly what we are doing manually. So this defines a pipeline. It says it can run on any agent. It has two stages, a clean stage and a build stage. In the clean stage, it has one step called git directory. And in the build stage, it has multiple steps. So it says steps. The first is check out the code from the Git repository and run the maven build command. Now, if both are successful, then the post build step on success is this. Okay, so you can do post on each stage or you can do post on all the stages. So post means in the UI, you saw the post build actions, right? That section. Okay, you can say post, and then you can specify post actions based on if your pipeline is successful or failure. If it is successful, we want to do that. If let's say a failure happens and you want to send email out, then I can write steps to send email out for the failure, for example. Okay, I have few things right now commented out. If you want, you can use it later when you learn Docker. This pipeline can also build Docker images from your package. Okay, but you're not learn Docker, so those are right now commented out. Okay. So what we are going to do is we are going to use this pipeline to create a new project. Okay. So once you have coded your pipeline, right, you're going to create a new pipeline project inside Jenkins and then point to this pipeline code. Okay. So how to do that? So let's go back here. So this time we are going to build a new project. So go to the dashboard. And we'll say new item. And we'll say same thing, calculator. But this time we'll say the name is pipeline. So when you look at the item types, you're not going to select freestyle project, you're going to select second option, pipeline. Okay. And then click on OK. So since you have selected a type pipeline, now it is going to expect a pipeline code which you want to execute as part of this. You can write the pipeline code right there in the UI, but that will defeat the purpose. We are going to use the pipeline from the project. Okay, I'm going to show you how to do that. You can put the description here. Calculator. Most of the options are same. Instead of source code, now you will see a pipeline.
When we select GitHub project.
No. So now what it is saying is that here is your pipeline. You need to define your pipeline code using Groovy directly or pull it from the source control. Okay. So for example, if you just wanted to do some hello world pipeline using a Groovy script, you can use a script here and say, hey, I'm going to use a script and script generator. It's interesting. And it's script editor. Okay, let's go to the pipeline from SCM because that's what we're going to use. So our SCM is Git, right? And then you need to give the repository URL, which you're going to give the same as our calculator. Okay. And then it is going to ask you the script path, the file where is the code within the repository. So if you're using the Windows, use this file, Jenkins win file.
We should become
Yeah.
again.
Here, see. There's a Jenkins file underscore win.
In the previous step.
Yeah. Here. So you say my pipeline script is in the repository in the GitHub. That's what we are seeing, right? Then we are giving the repository location. And then within the location, which file contains your pipeline code is this one. Okay. Dot underscore win. Jenkins file underscore win. Because I have two different scripts, one for Linux and one for Windows. Windows uses a bat command and Linux uses a sh command, shell command. Okay, so it's not going to ask you anything else because it knows that everything you want to do in pipeline is in that file code, right? So once you're done that, you just save it. So here you are not specified source code repository, nothing. You just specified that where is my code for running the pipeline. The actual pipeline code is in that file. Okay. So let's try running this. Let's click on build now and see if it doesn't run into any issues. Because it needs some configuration, but I hope most of the things should be easy. So if you go here, it should tell you what it is doing. So always, if you want to find out what the pipeline execution is doing or any project execution, you can always go to console output. So if there are problems, it will show you where the problems are. If there is some issue, it's like, no. Successful, huh? That's good. So it did exactly what our UI project does. Okay, but through coded pipeline. So now if anybody wants to change anything, they have to go to my GitHub repository code, they have to change it, create a review PR, I have to review it, and then if I like that, okay, this change is needed in the pipeline, I can approve it, and then that's how you manage it. Make sense? That's what infrastructure as a code means. This is like a CI as a code. If you want to build any pipeline in CI, this is how you are going to do that. Okay, most of the corporates typically they would want you to do pipelines instead of creating a UI projects.
This way is most common?
Yeah, this way is the most common. Okay, so now if you go back here, in fact, there will be slightly a different UI. You can see the stages and everything. So if you see in the pipeline, you will click on stages here. So check out SCM is a stage, clean is a stage, build is a stage. So what happens is like if let's say these two stages passed and this failed, actually you can rerun this stage only, saying, hey, I want to rerun this stage. Make sense? So if some of the stage failed, you can start your pipeline from there, from that particular stage. Just another advantage of doing pipelines. If you do through UI, you will have to restart from the beginning. If you do stages, you can break up stages in the pipeline. Then if one of the stages failed, you can say, hey, I want to start rerunning the pipeline from this stage onwards because others actually passed. So with a long running pipeline, it will save you a lot of time. Okay. And then you can go into the details like what does this mean, and then what are the commands? Did they pass? Did they fail? If they failed, you will see like a red and cross mark here, for example. Make sense? In the pipeline syntax, can you click on that? So this is where you can do the snippet generator. So let's say you don't know pipeline syntax, and then you want to do something, right? You come here, and it will give you sample steps. So for example, if you click on this drop down, there are lots of things. So let's say you want to build some Maven project, right? Or you want to run some shell script. If you click on that, it will give you a shell script example. So you can write like echo hello world, for example. You want to do that, right? And you can say generate a pipeline script to say this. This is what a step will look like in the pipeline. Make sense? Or let's say on jobs. Let's say you want to do a Git clone, right? So specify a repository and you say branch, right? And that will generate a command for you here. For example, if I say, hey, I want to get the code from here, I say generate a script, it will tell me what I need to write. This is how I have written my pipeline. Make sense? Right? Each step you can generate the code and then copy and paste into your pipeline wherever you need it. Right? And you can, if you know Groovy, it's better. You can like use that syntax to do like if you wanted to do if else statement or you want to do while statement, you can use that Groovy script if you wanted to do certain things during your pipeline execution. Okay. And again, all of these are based on the plugins, right? So if I want to like do a JUnit archive, right? So I can write all of these things and it will generate a command, the JUnit archive command, for example, right? So there are a lot of example references and things like that which can help you. But ultimately, the idea is that you want to code your pipeline and then run your pipeline through code, right? That way you can better version control your pipelines. And then if there are any issues, right, you can figure out quickly. Okay, let's go back. So what are the best practices for Jenkins, right? First is always secure Jenkins. We know that, right? So that's what, I don't know if you're secure Jenkins. You didn't create a username password, right? No, right? Okay. So typically in Jenkins, right, when you create the first time that when you install, it will ask you to create some username password, and then additionally you can create more users and passwords, right? Now that is for the learning purpose. In organizations, you will integrate your Jenkins with the Active Directory, for example, right? And from the Active Directory, you can specify who will have access to what kind of access to Jenkins. Okay, so that's first thing, right? Second is use folders to group Jenkins projects logically. Means don't put everything on the dashboard, right? Because you might be working with hundreds of projects. So you need to know how to logically divide the projects. either department-wise or infrastructure-wise or location-wise, right? And then create those projects inside those folders. Backup Jenkins home regularly. This is very important. Specifically, if you're not on a cluster, typically in the big organizations, you will have unique, I mean, the Jenkins cluster, which you will have 3 copies of server itself. Like I said, one server goes down, the other server will be able to take care of it. Right, so the configurations and everything will have 3 copies on each server. So if one server goes down, the other server will take up that load. Okay, but if you're not in that scenario, always take the backup of the home directory. So if something goes wrong, if that server crashes, you have all the configurations to reload. Okay. Always do clean builds. Again, it depends because this might hit performance. Typically, you will do clean builds if you are going to deploy in production. But for dev, you can live with incremental builds. Okay. Integrate tightly with surrounding ecosystems using plugins. As I said, if you need to do something as part of your, CI practice, either it is a code quality or test quality or anything else, you make sure that you install those plugins and use those plugins. Okay. So prevent the resource collisions in jobs. Again, I showed you few options for that, right? Meaning when you schedule the jobs, right? Make sure they are not aggressive, because they are aggressive, you will have resource collision. There's lots of projects will start building unnecessarily, and then there'll be a resource crunch and resource collisions. Okay, so you want to avoid that, right? So use the right options to make sure that you have enough frequency of the builds, but they are not aggressive. Okay. Set up email notifications. This is very important. So ultimately, what this is all about, the early feedback we are talking about, right? Meaning, if your build fails, you want to tell the developer immediately that the code change you made is now failing the application. I'm not able to build the application, so go and fix your code, right? So by default in Jenkins, if you have set up a mail server, right, if the build fails, it's going to identify whose code break the build and it's going to send email to that person. How? Because you see that it is integrated with the Git. When it gets the code from the Git has the information of who did the last check-in, right, on which this build started, right? So based on that, it can identify the Git user who did the code change and because of which this is failing. So it will take the email of that user and going to send email to that user.
It will take care of it. It will send an email.
No, Jenkins will send. Jenkins will get the information about the user from the Git. Makes sense? So I can show you that. So if you see closely here, pick up any build. Right? It knows the revision from the Git. Make sense? So this revision has a user who did do the commit. This revision is basically commit number in Git. So if you go to Git, it will tell you which user actually did this commit. And then it will retrieve the email information of that user from the Git and send the email to that person. Okay. How do you do that? Again, let me show you a few things quickly in the manage Jenkins part. So if you go to here, go to manage Jenkins. Mm. And I think it should be in tools. Click on tools. So this is where you can configure your Maven, your JDK, your Git, your Gradle, and so maybe it's not here. So let's go to the system. I think it might be in the system. Email plugin should be there. So again, if you don't have an email plugin, you will not see those options. So by default, all those plugins get installed. If you're in the system, so search for email and SMTP server. This is, it will show you where to set up all of those things. System directory. So what are the, see here, number of executors, you set it up here, right? Somebody was asking, right, why it is 2 here. This is where you're setting number of executors for this node. Labels, this is where you would say it is a Linux agent or a Windows agent, and then based on the label, it will select where to, build your, run your builds. Okay. Let's see, what are the other things? This is where you specify the email, right? You say her system admin email address. So when it sends an email, it will send email from this account. Okay, so if I say, hey, this is system admin at ITEXPS.com, or maybe DevOps at ITEXPS.com, right? This will be the email coming from, right? So when user sees the email, this is where the email will be coming from. Okay, and then let's see here. Let's see. Yeah, email notification, right? You specify SMTP server, your mail server, right? Default user email suffix. What it means is that you can specify which user you want to send email to automatically based on the project, or if it is not specified in the project, it will use this default user. So for example, if you want some, you want your emails to go to some Scrum Master's address, right, or DG, right? You can send it up to a distribution list saying Scrum Masters at ITEXPS.com. So all the Scrum Masters will get an email, basically, right? So that's a default if you do not specify a specific one into the project. Okay. You can also specify what content goes in the email. What will be the content of the email, right? By default, it is template saying, hey, this build number is successful or this build number is failing. And then user can click on that link to actually go and see the result of that build. That's a default template, but you can change the content, right? Do you want content to be an HTML or text, for example? And then basically you can say, what are the default recipients, where they can reply to your emails, I mean system emails, if it all replied. What is the subject line? So by default, subject line is going to be like this: your project name, the build number and status. So for example, if your project is calculator, build number is 19, and if it's failing, subject will be calculator, build number 19, failed. That's what your subject line will be. These are variables automatically populated from your project name, your build number, and the build status.
Is there any way to get the, I guess, log file
Uh,
to show you any details of the email so you don't have to come logging in?
Oh, you mean like the log itself saying, hey, what went wrong?
Yeah, or let's say it was successful and you just want an email so that you can review what occurred.
Yeah, so what it does basically, if you look in the default content, they send you a URL. So you click on the URL and you'll be directed here to exactly that builds, and then you can look at the console output. If you want to put that content in, you can still modify that. So basically what you can do is, let me show you. So this is all default, right? Which applies to all the projects. Let's say for your project, you want to send a detailed email with some additional information. I think Michael was asking, right? So you go here and go to your job, for example. It's going to take time. So in the configure, go to a post builds tab, and there should be a step for sending email. That's where you can specify other things or specific things to your project.
Under add post build action email.
Yeah, email notification. If you click on that, it will show you the same things again. And then you can change the content, you can change the subject and everything. But Michael's point is like, if I want specific things from my log, which I want to include, right? You might have to do some more work on that. What you need to do is when you write a Groovy script, you have to capture those details and store in a variable, and then use that variable into your email. The way we are using the project and those standard variables, you can create a new variable, put those content in, and then use that variable into here. For example, if I select editable email notification, right? And here, let's say I want some more log information. I would have stored into a log some variable, and then I'll send it from here. Make sense? So that way you can modify and create a custom emails for each of your projects if you want. So where this log info will come from in your Groovy script, when you run the Maven, for example, you may want to do redirect output to this variable and then capture everything in the variable and put that into the email content. Okay. So that can be done. What else we are talking about? So those are a few of the things you need to know on how to configure that in Jenkins. Let me quickly show the security part as well. Already over the time, but give me 5 minutes. There's a couple of important things I need to show you on Jenkins. Let me go to the here itself. Jenkins. You go to credentials, right? Here you can create credentials. Okay, so what are the credentials here? So let's talk about it. You can add credentials, right? So Jenkins is also kind of credential manager. which can manage your credentials. So what will typically happen is that you are a DevOps engineer, right? You are not a developer, but you are responsible for writing the pipelines, building the pipelines, right? So in order to do that, you need to have access to all the Git repositories of your company, right? To manage all the builds, right? So understand this, the Git typically is for the developers. They are going to put the code in, right? But Git is for you as well, because you are going to check out that code and run the build. So you also need access to the Git repository, okay? But the best practice for DevOps is that when you are managing, as a DevOps team, you are managing all the projects of your company. Maybe there are 10,000 projects, right? You are not going to create individual accounts in those Git repositories. You might create one common Git account, say Git DevOps, and then allow access to all the repositories to that account. You will have control over the credentials for that Git account. What you will do is you will come here and then create that Git credential and then use this Git credentials to build your pipelines. Make sense? So this is where you can create your credentials. So you can say, hey, for example, your Git credentials might be something like this, system like this, username with password, and you will say username is DevOps, and password is whatever you keep it, right? Paste, right? And then you will give it ID saying, hey, this is for Git access. Okay, and then you will create this credential. Now this credential will have access to all the repositories. Okay, so now when you build your project, remember like in the Git, it was asking for the credentials. You're going to go to that drop down, it will show you this one of the values of Git access. You will select this Git access, right? So what happens is whatever you stored here as username password, you're going to use that username and password to connect to the Git repository to check out the code. Same way, let's say for example, you need access to some other system like a Sonar, and you want to dump the results in Sonar, right? Or you might need an access to the Docker repository where you're going to dump the Docker files or Docker images. You will create your Docker credentials here or Docker registry credential here, and then you will use these credentials to dump your Docker files into Docker registry. So in short, as a DevOps, right, if you're part of the CI, and if you need credentials to access different systems like Git or Sonar or your Docker repository, or you might have some other artifactories like JFrog artifactory, all your credentials will be stored here, and then you will be using these credentials IDs to access different systems. Make sense? So this is what this credential manager is for. This credential manager is for you as a DevOps to connect to different systems where you need access in order to do your CI job. Make sense? Okay. The other credentials are to secure the Jenkins. That is different. Question?
Yeah, with securing the Jenkins, my understanding is that this ends up in a file. Jenkins has the decryption key, and that creates a security issue.
Yes.
How do you go about securing that to make security people happy?
Okay. So this you can also use a different credential manager. So for example, if your organization has a keywords, right? What you can do is if you integrate your Jenkins with keywords in the credential manager, your keyword will appear. Like let's say your Azure keyword. And then from there, you want to bring the credentials in. So here in the credential manager, you select a vault and then put the vault credentials to connect to the vault and get the credentials from there. That way you can make your security people happy. If this is
So use So use the security keys in like AWS or
AWS, yeah,
Azure,
sure,
or use like a hashy vault type
exactly.
thing.
Yeah,
Okay, and then that eliminates anybody being able to get to stuff with and decrypting it.
exactly. Yeah.
Thank you.